Hey there, welcome back to Verifying Identities. In this video, we are going to go ahead and continue to verify trigonometric identities through the process of substitution using Pythagorean identities, using reciprocal identities, and quotient identities. Okay, so let's go ahead and hop to it. I hope you have been working with your flashcards and kind of studying these. Now, this example here is actually fairly simple. They say convert to sines and cosines. I get really excited when I just see just basic trig functions, linear trig functions. I don't have quadratics. When you have quadratics, generally you're going to use Pythagorean identities, and then if you have like pluses and minuses and other stuff going on, it can get complicated. But this one actually is very, very straightforward. So I'm going to convert everything to sine and cosine. So tan theta, that is tan x, that's sine x over cosine x, and cosecant x, well, that is 1 over sine of x, okay, and what happens is that both of these end up canceling, okay, and we get 1 over cosine of x, and that happens to be secant of x, and done. So that one was simple. Here is a practice problem. Please go ahead, pause the video. I want you to try this one. Okay, hopefully you pause the video, and here is the answer. I'm going to go ahead and do some magic. Whoa. Okay, so first, you go ahead and you use your quotient identity, right? You put it in sine and cosine. Okay, then I can go ahead and simplify some stuff, and just last but not least, you use your reciprocal identity. Very straightforward. Okay, so what we're going to go ahead and do in this example, it says convert to sines and cosines. I hope you notice on the left you have two terms. On the right, I have one term with two different trigonometric expressions. So I'm going to go ahead and convert this to sine and cosine. So tangent is sine over cosine. Cotangent is cosine over sine. Okay, and then next what I'll do is, in order to add these, I need to have a common denominator. So I'm going to multiply by sine of x on the left. Okay, and then on the right, I'll multiply by cosine of x by a factor of 1, right? So I'm not really changing this. I'm multiplying by 1. Okay, so this is going to become sine squared of x over sine x cosine x plus cosine squared x over sine x cosine x. Okay, and I hope at this point you kind of see what's going to happen. I have sine squared x plus cosine squared x all over sine x cosine x. Okay, and in the numerator we have a Pythagorean identity. Sine squared plus cosine squared equals 1. See, those flashcards are starting to pay off. Sine x times cosine x. Well, here, what I can do is I can go ahead and separate the denominators, because I can multiply by 1 over sine x times 1 over cosine x, and this gives me, right, my 1 over sine x times cosine x. Okay, so that's why it's a legal move. You can't do that if, like if I had a 2 in the numerator, I couldn't do 2 times sine of x over 2 times cosine of x. Okay, you'd have to approach it kind of differently. But anyway, this becomes, sorry, I lost my place. Here we go. This becomes, using the reciprocal identities, we get cosecant x times sine of x. No, secant of x. Okay, and is that what we wanted to prove? It is. QED, we are done. All right. Okay, so please pause the video. Here is an example. I'd like you to go ahead and try that, kind of using those same processes. All right, hopefully you pause the video. Here is the solution. Okay, so convert to sine, and then you get a common denominator, right? 1 minus sine squared, that is cosine squared using Pythagorean identity, and you get cosine of x times cotangent of x. All right, here is our final example, and in this example, we are asked to verify that secant of x plus tangent of x is equal to cosine of x over 1 minus sine of x. So I hope you notice in the denominator we have 1 minus sine of x, and whenever you have a problem like this, that kind of screams conjugate, right? 1 minus a trig function, which is linear, right? If it was squared, you could go ahead and do Pythagorean identity right away. So I'm going to multiply by the conjugate by a ratio of 1. So 1 plus sine of x, top and bottom. So this is 1, so I'm not really changing it. Okay, and I'm going to carry out my multiplication. Cosine times 1 gives us cosine of x, plus cosine times sine gives us cosine of x times sine of x. Okay, and in our denominator, 1 times 1 gives us 1. 1 times positive sine is positive sine, negative sine times 1 is negative sine x. Those two terms cancel, and I get negative sine x times positive sine x, which is negative sine squared x. So, okay, why did I go ahead and multiply with the conjugate? Well, now my denominator is a Pythagorean identity. I have cosine of x plus cosine of x sine of x all over cosine squared x. Now, why does that even matter? Well, because I can go ahead and I can split my numerator with the denominator. Forgot my variable. Okay, and this is legal. You can do this. We do this a lot in calculus when we are integrating, and my calculus students are kind of uncomfortable. They're like, can I do this? Yeah, like this is totally valid, right? Because I have two fractions with the same denominator, common denominator. I can add them together, add the numerators. So we're doing this because I hope you see some cancellations, right? This ends up being 1 over cosine of x, okay, plus up here we end up losing a cosine x, so then we have sine of x over cosine of x, which equals, I know what I see, I don't know what you see, yep, and that's what we want to verify, secant x plus tan x, right? I know that 1 over cosine x, this is secant of x. And actually, you know what? To be fancy, I'm going to go ahead and write it over here. This is secant of x, right? Plus sine over cosine of x, that's tan of x. And hey, we showed exactly what we wanted to show, right? So QED. I'm going to get rid of that equal sign there. And we're done. That's it. Okay, here is a practice problem. Please go ahead, try this one. I hope you paused it. Here is the solution. Okay. All right, so same kind of idea, multiply by the conjugate. All right. Here we have our last example, and in this last example, they recommend working with each side separately, okay? And you can go ahead and do that. That is a valid process, all right? So what I'm going to do is I'm going to carry on this idea that we just looked at in the last example. Over here, I have 1 minus sine theta over sine theta. So I'm going to split this. So this would be 1 over sine theta minus sine theta over sine theta. Now, using my reciprocal identity, I know that 1 over sine theta, that is cosecant theta minus 1. Okay, and I mean, I'm kind of stuck here. So here's where I'm going to go ahead and work on the left side. And what I'm going to do is I'm going to swap out cotan squared theta for the Pythagorean identity, which is cosecant squared theta minus 1. Now, where the heck does that come from? Again, we get our foundation here, sine squared theta plus cosine squared theta is equal to 1. And if I divide everything by sine, right, we get 1 plus cotan squared theta is equal to cosecant squared theta. Okay? All right, so what I'm going to do is I'm going to swap out cotangent squared theta for cosecant squared theta minus 1. So this becomes cosecant squared theta minus 1 over 1 plus cosecant theta. Okay, and why would this be beneficial? Well, now that I have cosecant squared theta minus 1, I actually have a difference of squares. I have cosecant theta plus 1 times cosecant theta minus 1. Okay, and all of this is over 1 plus cosecant theta. Okay, and just note, right, that aren't these the same thing? Okay, so those cancel, and I have cosecant theta minus 1 is equal to, hey, and what do we have on our right side? We had cosecant theta minus 1. And guess what? We're done. So you can do that. You can work from both sides, believe it or not. That is valid, right? And I could easily go ahead and work backwards. I could kind of go ahead and do that, okay? All right, here's the last practice one, okay? Please go ahead and try this one, and I will post the solutions. All right, so here is the solution. Okay, if you separate them, again, swap out with the Pythagorean identity on the left, and then factor, we get secant theta minus 1. All right, that is it. That's verifying trig identities, and I know that that's not the most easiest kind of lesson in the world, right? Lots and lots of practice, lots and lots of struggling, trying stuff, realizing you're wrong, memorization. Use the flashcards. Catch you next time. Be safe, be easy. Peace out.